Hi everyone, thanks for checking out this video. So I was thinking that it would be a good idea and hopefully useful for you guys if I made some videos kind of introducing a couple Python libraries that are widely used in the data science field. So these are going to be some libraries that are useful for data analysis, whether you're doing like computational biology and bioinformatics or just like data science in some other field like more broadly. So I'm going to be starting off with like one of the most famous and really best and most useful libraries today called NumPy. And the goal in this video is not to give a comprehensive course on it. I will link in the description note to some like more advanced comprehensive courses. But today's video, I'm really just trying to give like a brief introduction. But I think even giving a brief introduction, I can still cover like 90% of what NumPy is used for by people working in the data science field. I mean, I'm kind of going off my own experience here. Been working in this field for a pretty long time, and I think what I cover today will cover like 90% of the everyday use cases of NumPy. So that's kind of my goal for today. Just give you guys a brief introduction, enough that you can like know the basics, know what it's used for, and like if it comes up in a job interview, you can at least like say that you know it and talk a bit about like what it's used for and stuff like that. But yeah, just kind of like a brief introduction today to get you guys going with the basics of it. So this is the library I'm talking about, NumPy. It was created by Travis Oliphant. And it's basically, it can do a lot of things, but like the main use is for storing data in arrays. And the arrays can be multi-dimensional. And yeah, you store data in them, and then they can be used to perform like mathematical operations on the data. Okay, so let's get started. So I'll just, first of all, just starting at the very beginning, show you guys how to import it. So we say import NumPy SNP. This is kind of the convention. It's just when you're importing things, sometimes there's like a convention of like what to call it. And of course, you guys don't have to import it as NP. You can just say import NumPy. But if you're looking at like other people's code, this is kind of how most people import it. They call it NP, just for short, kind of a convention. But again, you guys can call it whatever you want. But I'm just keeping the convention for now. And yeah, so let's just start talking about arrays. Let's just talk about like the main like core functionality here, which is arrays. So I'll start off by like kind of reviewing how we would be storing data if we weren't using NumPy. So if we weren't using NumPy, we'd be using this Python object called a list. This is like the basic Python data storage, like data structure. So it would be like, say for example, test list equals 1, 3, 5, 7, or whatever. So yeah, this. If you guys just hopefully know the basics of Python, you can just store your data in a list like this, and then you can access the data like through indexing like this. This is how you get the first element, second element, third element, you know, etc. But now I'm going to show you guys this NumPy object called an ND array. That's ND for n-dimensional. It can be multi-dimensional. But I'll start with just like a one-dimensional array that we would use to like replace this this list. So we're going to say test array equals np dot array, and then yeah, just put some like numbers in here. Yeah, so let's just see what we get with this. So let's just take a look at this. Yeah, so if you guys see here, this is what the array kind of looks like when we print it out. It's similar to a list, kind of the similar kind of data structure. But the type isn't called list, it's called numpy.ndArray. Again, we said nd is for n-dimensional. It could be multi-dimensional. But this is just one-dimensional for now. So yeah, let's just talk about a little bit of like the basics of this. So so the indexing is going to be the same if we let's say we print test array, and we want the third index, which is index number 2, because remember, it starts at 0, same with lists. So this should give us 8, right? Yeah, so indexing is basically the same. A couple differences, though, just like start off with some differences, too. With lists, you can use like many different types of data in the same list. Like we could put a string in here, and this would be fine. Like this would be valid. But if we try to put a string in here, it's not really going to work because, I mean, we still got a result, but in order to have this string in the NumPy array, it had to make all of them strings. So yeah, with a NumPy array, you can only have one data type in the array. So if it has a string, then it has to be that all of them are strings. Yeah, you can't be like mixing and matching data types like that. Or if we put like even just a Boolean in here, then it actually, this is kind of interesting. It converts it to 1. And then if we were to say like false, converts false to 0. We could also, if we want to like change around the data type, we can say dot as type, and then we can cast these to floats if we want to. This is how we do the casting. But yeah, there's just a little bit of the data types. This seems like a disadvantage at first, that you can't like mix and match different data types, but once you guys like really start using this in real life settings, you'll see that the advantages that come with this outweigh the disadvantages, because NumPy arrays are a lot faster to work with than lists. But yeah, so that's just a little bit of the basics. Maybe show you guys like a couple more basics. Let's say we want to get the length. To get the length, we'd say test array dot shape. Yes, we got length of 6 there. Just again, similar functionality to the list, but different syntax that we have to get a little bit used to. And then yeah, maybe I'll just get rid of this and maybe add in a couple more numbers here. Yeah, so one of the other advantages is that it's kind of easy to do math operations like over the arrays. So there's a lot of like built-in NumPy operations that you can do. So I'm actually just going to be a little bit lazy for a second and just copy and paste a couple of these in to show you guys. So these are some examples. Again, we have these are all NumPy functions. So we have np.max. That'll be the maximum value within the array. np.min, minimum value. np.mean, that's the mean, of course. np.std, standard deviation. Maybe also throw in median in there. And yeah, there's just a lot of like useful built-in like math functions that you can use, and just statistical functions and stuff like that. So if you're working with data, you can already start to see like the advantages of using NumPy. It's just easy to store the data, and there's a lot of like easy built-in stuff that you can do in terms of functionality. Okay, so yeah, a couple more things I'll show you guys before we get into like the multi-dimensional arrays. I'll show you guys how to cast lists into arrays and then back to lists. So we have this like test list here. I'll actually just get rid of this for a second. Comment this out for now. Test list. So yeah, so this is just like a regular Python list for now. Print out the type to also show you guys. Yeah, this is just a regular Python list. So we can cast it into a NumPy array like this. So we say test list. We'll just keep the same name even though we're changing the data type. np.array, and then yeah, test list, and then we'll print out the type. So yeah, we've successfully cast it into a NumPy array. And then we can also go the other direction too. So now this is, so I'll show you guys actually, yeah, using this test array. Let's say we want to cast this NumPy array into a regular Python list. We would just do that by saying test array, keeping the same name, equals list, and then test array. And then, yeah, print it, and then print the type of it. Yes, that's just like a little bit of usefulness if you guys want to go like back and forth between the different data structures, NumPy arrays, and Python lists. You can go back and forth like very, very easily. So that's just kind of adding to this usefulness of NumPy. Oh yeah, so another thing is that like NumPy makes it easy to do like mathematical operations on these arrays. Like other than the stuff I was showing you before, like these built-in NumPy functions, you can do like array arithmetic. Okay, print test array, space out a little bit, and then print test array times 2. So you can see that it's easy to like multiply the array by a scalar, for example. So we're able to just easily, super simple notation here. We could very easily just multiply every element in the array by 2. This would not work for a list. I'll show you guys what would happen if we were doing this with a list. This would not give us what we want if we use the list data type. See, if we use the Python list data type, if we say times 2, it just like multiplies like the data structure itself, and we just get literally two of the list, which is not really what we normally want. We wanted to like multiply the array by 2 as a scalar, and that's something we can like easily do with NumPy. But with the actual Python list, that it makes it a little bit harder. And yeah, we can do like more complicated like array arithmetic too. So we can add them, and we can sort of do like multiple operations in one line too, like this. Like this is adding the array to the array multiplied by the scalar 2. So let's see what we get out of that. Yeah. So it's just easy to do these like arithmetic operations, and it'll also work with like different arrays. Like we can say like test array 2 equals maybe test array times 10, and then maybe just say test array divided by test array 2. Yep, gives us the right result. So yeah, these are just kind of like simple examples, but when you guys are working with data sets, this functionality is going to make a lot of things a lot easier compared to like the regular Python list. It's going to make a lot of things easier on you guys. Yes, that's kind of like the basics of arrays. I'll also show you guys like a couple examples of how to generate like filled up arrays like pretty easily. So if we want to generate an array full of zeros, we'd say 0 array equals np dot zeros, and then shape. I'll keep it one-dimensional for now, but you guys could make it like multi-dimensional too. Yeah, so this just gives us an array to start with full of zeros. That's useful if you're like maybe iterating through some data set and you want to like keep a count of something, for example. You can do the same thing starting with ones. Yeah, just give us an array full of ones to start with. This, if you guys have watched my like ODE solving videos, this is one that I use a lot. So this is what's called linspace. So this is if we want to get like an array of numbers covering a range. So we'd say np.linspace, our starting point, our ending point, and then the number of numbers we want in that interval. So let's say we want like 10 numbers in there. So this is what you might want to like pass into an ODE solver if you're giving it all the time points you want to solve it. And then there's another one that's like similar to linspace, but slightly different, which is it's called a range. So say like a range test equals np.a range say like start at -10, go to 10. Except for this one, instead of telling it the number of numbers you want in that range, you just tell it like the step size you want. So we'd say like a step size of 2. Yeah. Yeah, so and then there's that too. It just counts from -10 to 10 going in steps of 2. Yeah, that's just kind of like the basics of one-dimensional arrays. So it just has some like basic functionality that can make a lot of things easier. And again, this is not like a comprehensive video. There's a lot more that you can do with NumPy other than what I'm showing you guys. But I'm just showing you guys enough to like get you going with the basics. And then from there, if there's some kind of like function or just like function that you want to be able to do on your data, I'd recommend Googling it, and chances are like NumPy already has some kind of built-in function that you can use for it. But I'm just showing you guys kind of the basics. This is definitely not like a comprehensive video. So next I'll show you guys like what NumPy is really useful for. Because yeah, it's like I said, like if you're dealing with like a one-dimensional data set, you could just use the regular Python lists, and although they're not as fast as NumPy arrays, you could basically get like kind of similar functionality out of them. But what if you have like a multi-dimensional data set? Like what if you have like a table of data that you're trying to work with? That's when NumPy gets to be like really useful, and like a lot more useful than Python lists. So I'm just going to be a little bit lazy, copy and paste in one to use for an example. So this is going to be our multi-dimensional, in this case, 2-dimensional array that we're going to be dealing with. So the way we kind of define it is as a list of lists. And if you're going to not use NumPy, you could still deal with this as like a list of lists in Python, but that would just make it a lot harder to do like the stuff that you might want to do with it. So yeah, let's just take a look at it first. We'll just print it out, and then print the type. Yeah, let's comment this stuff out for now. Yeah, so here's our data. You guys can see it's got rows and columns. It's two-dimensional array here. And the type is the same as before. The type is still a ND array, so it's got a lot of the similar like functionality as the one-dimensional arrays. But yeah, so I'll show you guys first just how to like get the shape of it. So going to the same thing. It's going to be the same as with the one-dimensional array. You're just going to say like the name of the array dot shape. And yeah, it tells us, yeah, 3 rows, 4 columns. That's just how we get the shape. And then this is getting to the point where like there's things that you can do with your data in this format that NumPy makes like very easy. So let's say we wanted to just like transpose the data. If we think of it as like a matrix and want to transpose it, NumPy makes that very easy. So we could just say like test equals np.transpose test. And then we can print the shape again. Yeah, so after transposing it, it flips it around, so now it has 4 rows and 3 columns. Sorry, I should have actually printed it too to show you guys. But yeah, it's like very easy. It takes like 1 line if you're trying to like transpose your table. Makes it like very easy to do. So that's just kind of one example here. The indexing is similar, but when you're dealing with like more than one dimension, you need to include like 2 index numbers. So let's say we want the first row and the first column. We would say test brackets 0, 0. It's going to give us the first row and the first column. Should be 1, I think. Right, 1. And then let's say we want the second row and the third column. Yep. And then just remember it starts counting at 0. So the first row is number 0. The second row is number 1. Same as with like regular Python lists. But since you have like more than one dimension, you just give like 2 numbers here, and you separate them with a comma. And if this was like a 3-dimensional array, which is also possible, it can be any number of dimensions, then it would just be another comma and another number. So that's how you do it for like a 3-dimensional array. Okay, so what if we want a slice of the table? So if we want to slice, the syntax for that would be like whatever row we want, for example, and then if we want all the columns in that row, we say colon. So let's just see what this gives us here. I'll get rid of a couple of these things. Yes, yeah, so this should give us. Sorry, did I say first? I should have said. Yeah, the second row, and then all of the columns in that row. Yeah. Yep. Second row, and then all the columns in that row. Yep. And then if we wanted, let's say the third column, or sorry, yeah, third column, and then all of the rows in that column, then we just say whatever column index we want, and then colon in the rows place, because we want all of the rows in that column. So that's how we get a slice of the array. And again, this is already something very useful because you can't really do that so easily with a list of lists. If you had a list of lists, not in like NumPy array format, it would be more difficult to be getting like a slice of the data like that. But so yeah, you can already kind of see how like the NumPy array is like a lot more useful than just dealing with lists. And so let's say if we wanted to like iterate through the arrays, let's say we want to just like go through every row and every column and just like check every number in this array. We could say something like for I in range test dot shape 0, iterate through with this variable I, and then so for every row we're going to say for j in range test shape 1. This is giving us the number of columns. So this is giving us I for the rows and j for the columns, and then we can just say print test ij. This is how you would iterate through like every element in here. So let's just try that out, show you guys. Yeah, and then let's say we wanted to iterate through all of the rows and just like take a slice of them. So to do that, we would just say for I in range test shape 0. We could just give a colon for the columns. This would like iterate through all of the rows and give us a slice for all of the rows. Yeah. Yes, that's just a little bit of like how to like navigate through your data. Show you guys a couple more things with arrays before we move on to the next thing. So let's say you want to like edit the array and like change some of the values in them. So say let's just see what we have for this test array for now. Yeah, I mean, we've got these numbers. Let's just say like for some reason with our data analysis we're doing, we want to set every number that's less than 5 to be 0. So let's just say we want all these numbers that are less than 5. We just want to make them 0 for some reason with this analysis we're doing. So the way to do that would be to use this kind of syntax. We'd say test brackets test less than 5 equals 0. So again, like very simple syntax. You could not get away with using like this easy syntax on like a regular list of lists, for example. But NumPy makes it super easy. So this is just saying like we give some condition. And we're basically saying like for this array, like if this condition is true, set those values equal to something, which in this case is we're making it 0. So we'll say print it again and then see. And yeah, so it worked. So after we print it the second time, we can see that all these values that are less than 5, they've been set to 0. Yes, that's just kind of more like usefulness of NumPy. So the last thing I think I'm going to show you guys with arrays before we move on to the next thing is really like one of the most useful things is if you're dealing with data and you want to save your data to a file and be able to load it in again into your program again. This becomes super useful if you're dealing with like really large data sets where getting them from scratch can take a long time. So once you've done some amount of analysis, you want to just like save your work and have it be like easy to read in into like another program without trying to get it again all from like a raw data file or something. So the way we save the data, if we want to save this like test array, for example, we're going to say np.save, and then the name of the file. So I'm going to call this just saved array, and then .npy. That's the like file type for saving the NumPy arrays to files, npy, and then the name of the array that we're trying to save. Yes, let's just see if this hopefully works. So then, if it worked, we should be able to see it here. Yeah. So this is the file that we just saved. It's called savedarray.npy. You can see I just listed the files in this directory, and this is now a file that we've just created with this test array that we were working with. So that's how you save it. Again, when I'm just using this like small test array, it seems like it wouldn't be that useful. But if you're dealing with like a huge data set that took a long time to get from scratch, and you want to just save what you've done with it so far so that you can use it in another program like without generating it all again, then this would be like super useful. And then yeah, let's say we want to like load this saved file back in. Just comment this out. Say maybe load test equals np.load, and then just the name of the file. Whoops, sorry. Yeah, so this worked. It loaded back in this test array, saved it as load test, and then printed it out. So again, that's if you guys want to like save an array to a file and then load it in again, that's going to be super useful. And then just to show you guys this possible, I'm going to quickly show you guys an example of just what an array would look like with like more than 2 dimensions. So it's like I said before, how we can generate these things, these like arrays full of like zeros, for example. I'm just going to show you guys like what it would look like to have a real like multi-dimensional one. So let's just say instead of having this be like one-dimensional, I'll show you guys first 2-dimensional. So this is a 2-dimensional array of zeros, 10 rows, 10 columns. What if we had like just something maybe 3-dimensional? Yeah, so this whole thing is a 3-dimensional array. It's basically like an array of arrays of arrays. You can think of it kind of that way. But yeah, it's three-dimensional, and then the way you would like do the indexing and stuff is all the same, except instead of having just like 2 numbers for the indices, you would put in another number because you have 3 dimensions. I'll print the shape too, just to like prove to you guys that I'm not making this up or something. But yeah, there's the shape. Just 3 by 4 by 10. At this point, I guess we can't really call it like rows and columns anymore, but yeah, it's just 3 by 4 by 10 for the data. Okay, so with what I just showed you guys, if you made it to this point in the video, what I just showed you guys, I think is enough to cover like probably 90% of what NumPy is used for. At least in my own work as a computational biologist and previously as like a general like data analyst and stuff like that. The stuff that I use NumPy for, I would say like 90% of it can be covered by like what I just showed you guys. Yeah, it's just super useful for like storing data in array format and being able to like easily do operations on your data and like save and load and things like that, and just working with like multi-dimensional data sets. But there is like one more thing I want to show you guys that I also use NumPy for, besides just the arrays. So the other thing I use it for is random number generation. I guess if someone wants to be like really technically correct about this, it's technically pseudo-random numbers. So maybe I'll actually just put that, pseudo-random numbers, but let's call them random numbers like for short. This is another use case of NumPy. This is not as widely used as their arrays, usefulness of their arrays. But this is something that I also use NumPy for, just for generating random numbers from a bunch of different distributions. And this is another thing you can do with like the more basic just Python random library. You can get some like basic random numbers from just by importing random and using that. But NumPy's like random number generators allow you to just get a bunch of different like kinds of distributions, and there's kind of like more you can do with them than just using like the regular random library. So I'll give you guys a couple examples. So let's just say we want to get a random number from a exponential distribution. We could say rand equals np.random.exponential. Yep. And then at this point, we need to kind of like look up what kind of parameters we need to give it. So it's a like NumPy random exponential. And we can just look up on their website what kind of parameters we need to pass in. So we need to pass in like a scale parameter for the exponential distribution. So I'll just say like scale equals 1, even though that's actually the default. And then just print rand. And you can see, keep doing it a couple times, we get different numbers. And the reason that this is like a lot of times better to use than just the regular like Python random library is that you can get like more distributions to choose from NumPy. I think, yeah, NumPy offers like more distributions. I don't think you can get like the exponential distribution and like the Poisson distribution and stuff, and sort of these more advanced distributions with just the regular Python random library. You might be able to get like the normal distribution, but I don't think you can get these others. But yeah, so we can also get like an array of random numbers by using this size parameter. So if we don't say anything for size, then it just gives us one random number. We can say if we want to get like an array of them, we can say like size equals 10, and then we get a whole array of these random numbers from the exponential distribution. I think we can also get like a multi-dimensional array too. So if we want 10 rows and 2 columns of these random numbers, then we can also get that. Even I think we can go even as many dimensions as we want. Really, it could be 3-dimensional if we want. Yeah. So here's a 3-dimensional array of these exponential random numbers, and then there's also like other distributions we can choose from. For example, we could do like the Poisson distribution. This one, it's going to be a little bit different parameter we have to pass in. So for all of them, like NumPy's website is pretty good, so you can always look up like what kind of parameters you have to pass in for whatever function you're using. So for the Poisson distribution, we have to pass in this lam parameter. So we could say lam equals, I don't know, 3. And yeah, so this is really good for getting, like, if you want to just get, like, one draw from a random distribution or, like, many different draws, I would say that, yeah, NumPy is good for that, and there's more distributions you can choose from than just the Python random library. Yeah, so that's really all I have for you guys for today. Again, this is not a comprehensive course on NumPy. There's a lot more that NumPy can do. But I think if you guys have made it to this point in the video, you have a good enough idea to like possibly see how NumPy can be useful in your own work if you're working with data. And I think if you made it to this point, you should be like well prepared to like possibly answer some questions about it in like a job interview maybe, or just be able to use it on like a coding like assignment or just project you're working on or something. There's of course more advanced things you can do with it, but I think what I've showed you guys today covers like 90 to 95% of like use cases. And of course, like I said, I didn't like exhaustively go through all of the operations you can do on arrays, but I would say if whatever you're trying to do with your data, if you have it in array format, I would recommend just Googling whatever you're trying to do, and like chances are NumPy may already have like a built-in function that you can use to do it. Yeah, it makes it like super easy to do a lot of stuff. So again, yeah, not comprehensive course here, but I'll also link to some more advanced NumPy courses if you guys do want to learn the more advanced stuff. But if you've watched all this, I think you're in a good spot to like at least know the basics and like be prepared for like most of the real life use cases that you're gonna run into working with data with NumPy. But yeah, if you have any questions, just let me know in the comments and I'll try to answer them. And thanks for watching and see you next time.